Hello, and welcome to our first show of Into the Terminal for the year. Welcome back, Nate. I hope you had a great break.
Absolutely. Happy New Year.
Thank you. So today we're going to be talking about archives in Linux. Um, so there's a command that kind of rises to the top amongst all others when we start talking about archives, and it's a super old Unixy utility called tar. And Nate, what does tar stand for?
So tar, it's not an acronym, right? It's actually a tar ball, right? Which is to signify taking all of your stuff and sticking it to a tar ball, right?
Uh,
Is there an actual
it
acronym
is
here?
an
No, tape
yeah,
archive, right. Tar stands for tape archive. You're quizzing me here,
that's
Scott.
right. Well, I mean, when you say that you're just going to be the color commentator, I get to stump you with questions all episode.
Totally. There will be lots of colorful commentary. But anyway, that's what I always
All right.
pictured tar was. I pictured like your things are stuck together in tar, therefore it's tar. But no, it's a tape archive.
Well, and they do use things like the term tarball to describe it,
Exactly.
which is kind of weird. But let's jump into the terminal, and we will start working with our first tar archive. So I've already created one for us to work with, and we'll work with more and also make some later in the episode. So here in my home directory, there's this file called backup.tar. And if we wanted to make sure what it was, we could do a file on backup.tar. And that tells us that it is a tar archive type file. And because of that, we kind of know what command to use to interact with it, the tar command. So we could do things like, if it's an archive, how do I see what's in the archive? So we can do a tar tf for a table of contents in the file backup.tar. And so this is all the stuff that's in there. So how do we, or why do we care about tars? Well, let's say we did something really silly, and actually, yeah, let me do that. We're going to do something like this. Whoops. It's something silly.
You've
And now if
deleted
I
your
try to manage,
HTTP conf. Why would you do
I
that, Scott?
know, because I fat fingered it.
You meant to delete the .conf.2024-0111, right?
Right, something.
From yesterday.
Um, but clearly, yes, Eric has commented that manager Scott strikes again. That's exactly what happens.
I was trying to clean up those old files and I deleted the wrong ones.
So clearly, without a configuration file, we can't start the service that would read that configuration file that tells it how to operate, like what ports it has and where it can find content. But luckily, before I made that mistake, I created this tar archive, which is an archive of files. And when I created it, I grabbed everything in the /etc directory. So I can extract all those files back out again. So if I do a tar x for extract, v verbosely tell me what you're pulling out. So it'll end up showing me a list of files that come out of the tar archive.
Always helpful.
From a file, from a file I'm about to give you, right, backup.tar. So there we go. It pulled all the files out. And if I look at my home directory now, there's this Etsy subdirectory.
Right.
Whoops, not /Etsy, local Etsy. And these are all the files. So I can just copy, not /Etsy, local Etsy, http conf, http.conf, to /Etsy, http conf, http. So I've put it back again, thanks to my very timely backup that I made with tar that grabbed all the contents of the Etsy directory. And
Just
now
moments
if I do my
before you deleted it, almost like you knew what was going to happen.
Exactly. Now when I start up HTTPD, seems good. Let's do a status just to verify. Right, so we're good. It's active and running. Everything's happening.
Yay, tar.
All right. Yay, tar. So that's the end of our critical path. Well, why don't you stay with us and we will talk about creating tar archives, using compression algorithms or compression utilities like gzip and bzip2. We'll also cover a couple other archiving utilities, specifically zip and dd. Stay
Right.
with us.
See you guys over there. And we're back.
And we're back. So don't forget to like the episode if you enjoy it, or subscribe to the channel if you want to get notified when we do more shows like this. And of course, if you know someone else that has a friend or is your friend and you would like to share some information with them, think they'll get some takeaways out of our show, please share it with them. All right. So diving deeper into tar. Because again, it's one of the most prolific archiving utilities on Linux.
Yeah, the number of backup scripts, quote unquote, that I've made that included tar is probably large. Because it's a very
Incalculable.
it's included, it's simple, it gets the job done. It's not sophisticated though. In fact, that tar that you made isn't even compressed, right? So
Yeah.
I think that's where you're going next though.
That is, but before we compress it, I wanted to ask what is actually in a tar archive. So if we take a look at less on that backup.tar, yes, this is actually what's in the tar archive. So what we see is a name of a file like Etsy, and then a bunch of binary data and permissions and ownerships and a whole bunch of other stuff. And then there's another file right there, Etsy mtab. And then we see its permissions and its ownerships and a whole bunch of other metadata about that file. Then we see Etsy fs tab. And so what
Right.
we're actually seeing here is the header um, of the directories that are being pulled into our tar archive, the structure. And then here's the header for this one file. And then we actually see the contents of that file. And this file happens
Wow.
to be text, which means that Les can show it to me because it's text.
It's handy.
So really, yeah. So we talked about tar balls and like putting things together. That's really what's happening here is tar just takes your file and it creates a header with metadata about your file. So when it's recreating it from the archive, it knows who owns it and what directory and what the file's called.
Yep.
And then you see the actual file's contents. And then you move to the next file. You get the header with all the information about the file and then the contents and then the header and then the contents.
So it's almost like it's just concatenated all the files, but separated them with metadata so that it knows where to put them back. It's not just a lump of data. It's a lump of data with a little bit of intelligence, right?
Right. And it's not just so it can put them back in the correct location, but it's also so it can put them back
Ownership
with
and
ownerships and
yeah,
permissions and
right.
SE Linux contexts and a whole bunch of other stuff.
Are those important?
I think so.
SE Linux
Because just like
context.
with our copy for httpd.conf, right? We wanted to make sure that it went back and was functional.
Right. So, I mean, notice after you decompressed it and put it back, it just worked, right? If the ownership was off, if the chmod was off, if the SE Linux context were off, those wouldn't work. Like, or
Correct.
it might work, but there's a good chance it won't work.
All right, and I see in the chat, Shantanu mentioned that Tar's tape archive, but we're not using any tapes, and that's true because we keep using the -f option, which says I want you to work with a file, and then when we create an archive, it creates a file. When I was passing it to the extract command, the -xf, is telling it I want to pull out of a file. And if you look at the tar main page, you'll see that there's like a whole bunch of other crazy options for things like controlling tape drives that
Yeah.
I think today is very seldom used.
I've never used tar in conjunction with an actual tape or tape drive or tape archive or tape array. What's the word I'm looking for?
You have lived a very sheltered life, Nate.
Yeah, well, I've never had to because all of the tape backups that I have done in my sysadmin career have had specific utilities that handle the tape mechanisms and the archives and whatnot. So tar is essentially, for me anyway, it's sort of outlived its life as an actual tape utility, and it's just a way to help me do backups that can later be picked up by a tape utility.
Indeed. All right. So let's shift gears a little bit and get a little bit deeper into some of the commonly used options with tar. So I want to show you something real quick. And let me make this human readable. So when we made this backup, as we just pointed out, it basically just takes the file content, sticks some metadata at the header of the file, and then gives you the file contents. Tar natively does not do any compression. And so when I grabbed the copy of the Etsy directory to make this backup, there's 21 megs of files there, which meant the backup is 21 megs in size.
21 megs, maybe
So
even larger because there's extra data for tar. Not much, but
true.
right,
That metadata is in there, and it would determine by like the number of files.
right,
Turns out, I think there are like 850 files when I checked it.
right,
So yes, there's probably some like several hundred or several thousand K. No,
right.
1,000 K would be a meg, but like yes, there is a little bit of space eaten up by that metadata, but it's not
Not
much.
much. No, I'm not trying to say that you're wasting a ton of space. I'm saying that it is probably a little bit larger than the thing that you backed up, which maybe isn't great.
Uh,
It's
Again, it's
livable.
going to be determined by like how
Right,
how many files are in your archive and things like that.
right,
But the kind of where we're going is the tar doesn't include any native compression. If you just or if you don't tell it. So there are additional utilities that tar can call to
right.
help with that compression. And we can use them by hand as well. So I can do a gzip on backup.tar. And now if I do a file on it, you'll notice that it got a new file extension because it's no longer just a tar archive. It's a GNU zipped tar archive. And so if I do a file on it, it says, hey, this is compressed data. The original file was called backup.tar, and then it gives me a little bit of metadata right there. But more importantly, um, with the H, it compressed from 21 megs to about 4.5 megs. And the reason for this is that gzip uses a combination of the LZ77 and Huffman coding, or the LZ77 algorithm and Huffman coding to do the encoding of the file. And it's really, really good at text data. And what kinds of files do we have in Etsy?
Text, bunch of text.
Text. Yeah. And so I had this
Maybe even all
backup.
text.
Maybe. But so I had this backup that was full of text content, and then I used an algorithm on it that's really good at text content, so it went to
Right.
a third of its size.
And text
Um,
is sort of always compressed really well. Binary data sometimes not so much, but yeah, text is a great thing to compress.
yeah. And binary data, like, there's really no compression utility that does a good job on binary data,
Right.
um, just because of how the algorithms and coding out or coding um, methodologies work. But gzip is like especially bad at binary. Um, and it's like moderate to poor on mixed content, where you have a mix of binary and text. Super awesome at text, though. So I manually called the gzip command. We could have created our archive and told tar to call the gzip command. So Nate, if I was going to create a new archive and I wanted it to be gzipped as part of the archiving step, what option would I use?
There's a flag for Z, which tells it to gzip, right? So tar what? So you did CVF before, which was verbose and created a file. If you add a Z to that,
Yep.
it also compresses it. And you have to tell the
Correct.
name of the output
And
file, so it doesn't just automatically add the .gz like gzip did. You have to tell it, what the file name should be, as you'd expect.
yeah, so we're going to create a file called var backup. And we're just going to grab all the contents of the var directory and shove it in there. So it's going through and backing it up. You'll notice that this is a mixed archive type. There was that little pause there. And what it was doing is it was pulling the SQLite database.
Right.
SQLite is an encoding. So there's some binary data in here too.
Right.
And so when we get done, we'll see a gzipped, right? TGZ or .tar.gz, both extensions kind of mean the same thing. Archive
Yeah.
of var, the 308 megabytes.
I mean, remember that in a Linux file system, the extensions are more for you than they are for the file system, right? You could
Absolutely.
end that in .bob and it won't care. It'll still treat it like a gzip if you use a gzip utility on it.
Which is why we have our friend file
Yep.
that will tell us what thing is in there, because then we know what tools we need to use. All right. So if we wanted to see its table of contents, we could RTF. Right, I want a table of contents from this file. Here's the file name. Whoops, I'm going to use my new file. There we go. And so it actually G unzips it, or G unzips a copy of it, shows the table of contents, and then puts it back. Actually, I don't know that G unzips it. It may just like look through the header and
I like that it figured out that it was a gzip without you having to tell it that it was a gzip. Because
yeah.
maybe it's just me, but I thought there was a time when you had to tell it. It couldn't detect. It would just be like, oh, well, this is actually not a gzip. It's a what's the other one it does? Bzip? Is bzip
Yeah,
what I'm thinking
bzip
of?
2, and we'll talk
Yeah.
about that a little bit too.
Yeah. That there's two different flags for it, and there was a point where tar couldn't figure out which was which. You had to tell it. But here it
And
did.
it's gotten even cooler because we can tar xvf. So the leading dash in front of my options is optional in
Right.
tar for Linux. But if you were cross-platforming Unix, you would want to include the dash to prefix your arguments. Notice I'm not using the Z flag for the extraction, because the extract part of tar will actually check it, see that it's gzipped, and automatically use gunzip or
Right.
gunzip to unpackage it. So, and that's also true for the other included encoding algorithm called bzip, or utility called bzip2. So if you have a bzip2'd archive, tar will just natively figure that out and call the right uncompression utility to fix it.
Right. Now you can specify, but you don't have to. And that's what I was saying before. You used to have to. It couldn't figure it out.
Right. And because I'm old, I end up specifying anyway, just because.
Me too.
You know.
It took
All
me
right.
forever to stop using the dash. That's probably a decade or more ago that you didn't need to use the dash anymore. I still use it from time to time.
All right, so we extracted all of our files out. Here, my local directory is now a var subdirectory, and there's the stuff that came out of my archive.
Right.
All right.
It sometimes gets interesting when you ask it to archive things that are special files, like if, I don't know, dev or something was included, or there's some stuff that's within var that are like weird links and whatever to other stuff. That's why you see some of these that look weird in the ls output.
Right. So that's a brief description of tar and a couple of the options, but there are other utilities out there. So Nate, what's another utility that we could talk about for archiving?
Of course, you're going to throw it back to me. I got to see what was next in the notes here. Oh, zip.
I mean, you can pick. Oh, zip. Okay.
Good old
So
zip.
why would we use zip?
So, for one, compatibility between Unix, Linux, and other operating systems. Tar is not a native archiving tool on, say, for example, Windows, but zip is. Maybe not native. I guess it is native now. It is included with Windows now. I don't know about Mac, maybe, but whatever. Interoperability, I think, is one reason to use zip.
Zip is also included in Mac. But yeah, that's exactly right. Like Zip has become this really popular cross-platform archiving utility. Turns out Windows can also open tar archives, and Macs can also open tar archives. So tar has also become cross-platform to some extent.
I didn't know. I didn't know Windows
Um,
could do tar yet. I know there was a long time where it couldn't.
yeah, they figured it out. Um,
Yay! Good job.
so
Can't
Zip
we just
works.
can't we just use ARJ or something? Remember those?
Stop it. And I see Richard Rios is screaming for RAR. I will
Yeah, I
very
see.
briefly touch on it later in the
Okay,
episode.
good, good.
All right. So zip is also pretty easy to use on Linux. So zip is the command, and you want to do a -R to recursively go through a directory tree. If you don't use -R, it only grabs the top level content of a directory and then won't go deeper into the directory tree. You call or you name your file, and then you give a list of files. And that can be a directory, and it'll, thanks to the -R, recurse through that directory, grabbing everything that's in there. You can also do a space separated list of files if you want to just kind of grab ones from around the directory tree and stick them together. All right, now, unlike tar, zip does native compression. So as we're looking at that added command or the added messages, you'll see that it says deflated. So it's compressing each individual files. It's sticking it into the archive. And if you want to list what is in the files or in the archive, you unzip -L. So this is all the stuff that's in there. And it also tells you how big in uncompressed size those files would be. And a little summary information down there at the bottom. And then if we want to unzip it, we just unzip. All right. So when I created this archive, I grabbed a copy of everything in the Etsy directory. And notice that there is no leading slash here. So when you unzip something, by default, it's going to try and put it in your current working directory, just like we saw with tar. And earlier, I had made an Etsy archive and untarred it, and all the files from Etsy were in there. And so that's why I'm getting this error message that,
Right.
hey, this file already exists. Do you want me to overwrite it with the one from this archive? Yes, no. Answer yes to everything, or answer no to everything. Or do I rename this file to something different? This is actually kind of nice compared to tar, because tar would just overwrite everything in that directory with new copies by default. So here, when it sees that there's a file conflict, it'll ask you what to do, which is handy.
Is there
All
is there a
right,
way to make tar warn you? I don't know if I've ever tried. There might
uh,
be.
I think there may be, but I've never used it because, again, I'm old and come from a generation where when you told the command to do something, it did it, and you
It
just
should
lived with
it
the
should do it.
consequences.
Yeah.
Right?
Yeah. We're
All
the
right.
folks that remove those confirmation prompts from roots aliases for copy and RM and
Exactly. All right. I have one more tool that I'm going to go a little bit more in depth in, but Richard is being so insistent on RAR, so I'll just move that forward. So
Okay.
RAR is another archiving utility. It is also cross-platform, so you can find it on Windows and other places. It kind of became popular in assembling broken down files. So if you had a really big file, you could use RAR to
Yeah.
make archives of it. But it was also really often used with Java packaging. And so there's
Okay.
files like war and ear that were actually created with RAR. Um,
Interesting. Yeah, I
yeah,
have to admit the most I've seen RAR is in the shadier side of the interwebs where you're like downloading pirated content. I got to be honest, right? Like that's where I learned about RAR. I mean, that's where somebody else told me they learned about RAR.
for shame, for
But yeah,
shame.
the nice thing about RAR is just what you said. You can have it chunk your archive up into separate pieces, which can then be reassembled later, which was really great for all of us back in the days when you were on really slow or unreliable internet connections. If you were in the middle of a large download, you could just say, "Oh, this one failed. I could go get that one." which has lots of uses other than pirated content. But that's where it was used a lot.
Right. And it is pretty heavily used in Java development. I don't know the background of why that is, but
Yeah.
it is. So
I didn't know
you may
that.
run into it if you're doing Java apps.
I learned something new today.
Oh, you're about to learn even more new stuff, Nate.
Yeah, I really want to know where you're taking this next tool, because if it's the tool that I think you're going to next. And Shantanu
Well, of
also
course,
wants to know.
we're also going to talk about DD, which is Device Destroyer.
Device Destroyer. I have a story, but I won't go into it now.
No, DD actually stands for Device to Device Copy.
Yes.
And so, actually, let me pull this up real quick. There we go. Okay, so I just wanted to have a couple terminals that I could interact with it on. So we've used DD several times throughout the show, and we do things like this.
Right. Just to make
Right.
files that we need to monkey with or to fill up drives or, whatever. DD has a lot of uses. Most of them useful,
So,
not just filling up hard drives.
and generally, DD takes a few arguments. So IF is the input file. Where's DD going to get its input?
Right.
To put into it where it's sending its output. So the OF is the output file. So DD basically just takes data from one side and passes it to the other side, just straight up, block for block copy.
Yep.
And so here, my input file is dev0, which is a never-ending stream of null characters.
Yep.
And my output file is dev null, which accepts all input but doesn't actually store it. And we use this a lot in the show so that we can like create a process and notice that it's not ending, because it'll just run forever, taking never-ending null characters and sending them to the dev null device.
Right.
All right. So usually when you run DD and it takes a long time, like this, you realize it too late, and it's because you like used the wrong output file, and now you've hosed your whole machine.
Yes.
Right. But in this case, it's cool. Like we're
We did
just
it on
transferring data between the two. Yeah.
Right.
But did you know that DD has a status that you can get?
That's groundbreaking. Earth-shattering.
So this is why I wanted the second terminal.
Yeah.
So DD was written to accept process signaling, specifically a signal called SIGUSER1. And so if we do a kill-L, these are all the signals that kill can send. Less. And usually if you kill with no options, it sends sig term, which is signal number 15. Some of you may have used kill-9, which sends the sig kill signal.
Yep.
Right, the signal number 9.
I wasn't
but
asking. That was the I wasn't asking signal.
Yeah. But I wanted to call your attention to this one, signal 10, SIGUSER1.
Okay.
All right, so if I do a PS and figure out which DD is running down there, so that's process 3450. So it's still running, never stopped, but because it got the SIGUSER1 signal, it popped out a status of how far it is, how long it's been running, and what's going on.
That's handy. Now, because it doesn't really have a destination size, I guess this data isn't exactly as useful, but you can get an idea of how much it's moved.
Right. And so especially when working with like, I don't know, an install ISO that you're trying to copy into USB drive.
Right.
If it's taking a long time, you can just kind of check to see how it's
like what's going on here? Can I get to lunch and back, or do I need to wait for this to finish? Yeah.
Yeah.
Should I go get coffee or should I go take a walk?
All right. When DD exits, so here I hit Control C, which is the interrupt signal, and killed it. Or it just naturally finishes because it's finished with the copy. It'll put out this ending thing that just tells you a recap of how much data it was copying. All right. So we also use DD on the show to make files of a certain size.
Mm-hmm.
So for something like that, it'd be DD IF equal. I like using dev0 because, again, this is never-ending stream of null characters, which is 8 bits each. And then you can output file. and I'm going to create in my current work directory a file called big file.
Yep.
And so I just did this and hit enter. Big file would grow until it used all the disk space on the local file system and then would crash out. Which sometimes I do because we'll do things like show file system full and when there's file system full. So this is a way to fill up the file system.
Yeah.
But maybe you don't want to do that. Maybe
Scott,
you want to.
You're letting people in on all of our secrets.
I am. It's an educational show, Nate.
Yeah.
Maybe I want to create a file that is 3 megabytes in size. So if I say that I want a block size, because remember that DD does block by block copy. By default, a block is 1K. But if I tell it a block size that's larger, it'll copy more hunks at a time. So I'm going to say 1 megabyte is my block size.
And I think you can use shorthand in there as well. So if you did like 1M, for example, it'll do megabytes. I think.
Well,
I should have tested that before I said it, but I think that's true.
Well, I'm gonna do it my way, and then we'll do it again your way.
Right.
That. All right. So notice the output says it wrote 3 blocks of 1 meg each, and we have a 3 megabyte file. And let's see here. 1M. Same difference.
There you go. Bash helping us out.
All right. So if we do ls/lh on big file, whoops, LH. So there it is, 3 megabytes.
Yay, 3 megabytes.
Right. So if you need to create a file of a certain size for something,
Yeah.
I've used this to create things like swap files. I've used it to create files that are then used as temporary block devices for things like Stratus to store additional content in.
Yep.
So
I've used it to make virtual machine disk images, like an empty disk image to add to a virtual machine.
Yep. That's a great example.
Which led to the story that I talked about earlier.
Well, and that's, I think, where we want to go last is like the probably the most common use case in the real world for DD is taking a file and putting it on a device. So like if you've downloaded the RHEL ISO and you want to put it on a piece of USB media to then install a machine from, you might do something like this. Nope, not that one.
Dev SDA? No?
Right. So this is going to take the file out of my current working directory called RHEL ISO, and it's just going to do a block by block copy to this disk device. Now this is where device destroyer is, or device destroyer is really an apt name for this tool, because you'll notice that when we're using the tool, it never asked, "Are you sure?" It just started making
just does it. Yes, exactly. And again, I wonder if someone should add a command there. Are you sure you want to overwrite this existing block device? Yes, absolutely.
So the word of warning is make sure this is actually the block device you want to overwrite. So you might do something like check your proc partitions file to verify that this is the disk you expect it to be.
I think one of the most powerful things about DD is its flexibility, but with that flexibility comes a lot of danger. One of the things I loved doing with DD was if you had a block device that for some reason you had to copy somewhere else, not just locally, but across the network, you could pipe DD through like Netcat and have Netcat listen on the other machine and pipe it into DD. So you could literally take a block device, copy it from one machine across the network to another, which is great if you're like, if you've got a logical volume, for example, that you need to make a block for block copy of, you could use DD to get that done. If you need that block for block copy to be on LV on another machine, you can do it across the network, which is just crazy powerful when you think about it.
Yeah. That would be pretty slick. So Nate, I did make a change to this command. What would happen if I ran this on dev SDA?
Well, so that depends on the VM you're on. I think SDA is our boot drive on these systems, and if it is, that would basically hose the machine.
Right. And then I'd be looking for maybe a tape with my tar on it.
Yeah, right. Then you'd be looking for a
'Cause-
tar to fix your mistake.
right. So this would very happily do a device-to-device copy from this file in my local file system, starting at block 0 on DevSDA, which is going to be my master boot record,
Yeah,
and then it'll overwrite boot,
it
and then it'll
takes.
overwrite whatever the next file system is.
I mean, in the amount of time it took you to get to the Control C key to stop it, it's already destroyed everything.
Yes. Well, it's at least destroyed boot.
It's destroyed everything
some-
that really matters. How's that?
All right. So yeah, let's not do that. And I'm just going to hit Control C because I'm not actually copying this device. So, yeah. But that's, I think, a more real world, what people would commonly use DD to do, to actually like straight up copy a file to a disk. We then plug the disk in, boot it, and everything's good. All right. The last major component today is bzip2. And I held it to the end because I wanted to have a whole bunch of different file types to use it on. So Nate, what is bzip2?
Bzip2 is another compression or compression tool similar to gzip.
Right.
Is that too basic?
No, that's exactly right.
Yeah.
The big difference between them is that bzip2 uses the Burroughs-Wheeler algorithm for doing its compression. And that means that maybe it's not quite as good with text as gzip. By not quite as good, I mean like you probably won't even notice. But in mixed files where there's a mix of binary and text, it does substantially better than gzip. So tar natively supports this too. When we're using gzip, we use the -z option to say I want to use gzip for compressing my tar archive. For bzip2, you want to use the -j option with tar.
Right.
Why -j? Because B was for something else already. So we
Right.
had to pick right. But we
Why
can call it
because it was the next one that wasn't used.
exactly. And so if we wanted to create a tar archive with it, we could do a tar dash JCVF.
Yep.
We'll call it tar dot, oops, back up. Dot TBZ2. And I've seen TBZ2, I've seen .tar.bz2. Either one of them, somebody should be able to figure out that it's a BZ2 compressed tar archive.
Yeah.
And so
I keep
all
seeing
right, so
drop
these
bear
are
at the
the
end of your file list there, and I keep thinking drop bear sounds like a really fun directory. Picturing
so these are
parachute
the
bears.
compressed archives that we did today that were all same copies of Etsy.
Yep.
So we see that the zip file is 8 megabytes. The BZ2 image is 4.1, which is the smallest, and the backup tar is 4.4. Right. So I said a slight amount of improvement for text, but not much.
That is significant between zip and gzip.
Yeah. Well, I'm going to blow your mind, Nate. Check this out.
Don't do that. I need my mind.
Do you know? All right. So a zip archive is an archive of already compressed files. And so typically when you try to compress something that's compressed, it doesn't work out well for you.
Yeah.
However,
well, I mean, it doesn't break anything. It just doesn't really help.
but it slightly did help.
Look at
Very
that.
little. But yeah, we could even make it slightly smaller with bzip2.
I had a friend back in the 90s who insisted that if you took a large file and a small file and zipped them together, the resulting file would be that much smaller because it was somehow like an average. And I'm like, it doesn't work that way. So
It was somehow magic.
I used to get archives from him that were like 6 levels deep, where he took the archive and like zipped it again with a little text file with nothing in it, and then again, and then again. And he insisted it was better. Like the numbers don't suggest that it is.
Yeah.
Anyway.
So typically You want one compression. Um,
Yeah.
and again, like nothing really compresses existing binary files well together. But mixed archives of both text and binary, you can get some better compression out of bzip2 than you can gzip, or potentially zip. I actually don't know that I've tested mixed archives between gzip and zip, but anyway. So that kind of runs us off the end of our topics today. I see Richard Rios is busy trying to get banned about RAR, which we've already addressed. Were there any questions that I missed, or was it just a lot of banter about awesomeness of archives?
There's been a lot of banter. We talked a little bit about DD in the chat. There were some sharing of stories.
The obligatory sharing of stories.
A little bit about the DD across the network thing, which is crazy useful, I gotta say.
Here in the year 2024, Nate, we use like devices like NASs for that kind of thing.
Yeah, well, this was like, you have a VM, right? We used to store VMs on logical volumes on RHEL using libvirt, which is another way to do it, and we felt that it was easier to manage that way. But sometimes you had to move that VM from one machine to another, and how do you copy an LV? Right? It's just not easy. If it was just a file, you could just move it over the network. But this way, you could actually pipe it into a file, or you could pipe it across the network and put it onto the block device at the other side. So, solutions to problems that not everybody has.
Fair enough. Fair enough. All right. So we talked about RAR, Richard. We're good.
We did. Stop mentioning RAR.
There is
the software.
There is one other compression utility you may run into, especially if you're super old like me, called compress. We actually don't use it anymore, although I think it still is supported on Linux. But like if you look at this this box right here, my 30-year-old SGI IRIX box, it didn't have bzip2, and I don't even know that it had gzip, but it surely had compress. And compress uses limplezev? No, it uses something else. But it's not as good as gzip or bzip2. So it may be out there.
Is it better than zip?
I've not tried it.
now we have to know.
So if you run into anything that has a .Z extension, that was the extension that was commonly used for compress.
I've seen those. The kernel modules used to be distributed that way, weren't they? With the .Z.
Maybe before we gzipped them.
Yeah, no, that's what I'm thinking. Like way back when I was first getting started with Linux, I remember seeing the .Z, and I always wondered what kind of archive that was, but I never really dug into it.
Yeah, it was from the compress utility.
Cool.
So yeah, well, welcome to 30 years ago, Nate.
Yeah,
past ourselves were amazed by future ourselves. All right, so I think that's the end of the show. So don't forget to like, subscribe. Oh, by the way, I don't know if you've ever commented on one of our videos, but it turns out we pay attention. So
we do.
I noticed in some of our other videos, whenever somebody comments, usually we'll give them a heart if it's just a comment. If it's a question, we usually do our best to answer it. So feel free to communicate with us beyond the chat.
Absolutely.
Yeah, Nate, next week, what are we doing?
Next week, we're going to talk about CVE mitigation on RHEL. So like, how do you find CVE data? How do we score things? How do you apply patches? And maybe some extended stuff within Insights about, how to see what's vulnerable and get a report and whatnot. So we still have to bake all that, but that's roughly what it'll be about.
Right on. And if you are confused as to what a CVE is, it's a common vulnerability or exploit. It's basically how we report security-related bugs with software. And most people discover what a CVE is when someone rolls up to their desk and goes, "Hey, are we susceptible to this thing I just read an article about today?" And
this thing that's on the front page news. What is it? And are we susceptible? Yeah.
Right. So having a good understanding of what it is and how it's scored and how do you interact with them, how do you validate that you've mitigated the CVE, that you've resolved that security problem, all great skills.
Yep.
To have. So join Nate next week and me, but mostly Nate.
Well, we
for
leaned on
that.
Scott this time. We'll lean on me next time.
Yeah. And then RHEL Presents is coming up in about a week and a half. That is Eric and Ryan Smith, and they're going to build applications with GitLab on RHEL. So they're going to have a guest speaker from GitLab
Nice.
to talk to them about building applications with GitLab.
That sounds like fun. I'm going to have to tune in.
I mean, I always tune in, but only because Manager Scott likes to heckle.
Totally. I never miss. I actually have a conflicting meeting with half of RHEL Presents every week, so that's why I don't always get to tune in. But maybe I'll skip that meeting and tune in.
All right. Well, man, the chat was great today, guys. Thank you
absolutely.
all for.
Good stuff. I see some new faces too. Awesome. Thanks for joining us.
Yeah, for those of you that are deferred viewers, appreciate you staying to the end. Join us next week when we talk about CVE mitigation.
And be careful where you point your DDs.
Absolutely. See you all later.
Yeah. Have a good one.